Just kind of diving in, let's just dive into Energy Toolbase, and I can show you how we perfectly model CGS Plus and CSS. Now, we can also look to model the Smart Export program with our new software update that is coming very soon. We anticipate that within a month or two, hopefully, and we'll be able to perfectly represent the Smart Export program with that update. But just kind of looking into here, I kind of went ahead and pre-built a couple scenarios that I wanted to show you here to showcase CGS Plus and CSS. So in Energy Toolbase, for those of you who are not familiar with our platform, essentially here facilities is going to be a meter. So here I just built out 1 meter, and we're going to be referencing a residential home with the use pattern of having homeowners gone during the day, Monday through Friday. Typical of what homeowners would be around this area, going to work, and the kids might be at school, coming home later and increasing that consumption. So let's take a dive into the actual profile that was built. So the first thing I want to show you here, we're going to look here at utility. Okay, so we have HECO, Hawaii Electric Company modeled, but as you can see, right, we have all the utilities for all the islands ready to go for you in our database. And all you do is you put your address of the location of the project in, select your utility, and then you're going to select the rate tariff within that utility that your customer is starting off on. So here for HECO, you can see all the different rate tariffs that we do have ready to go for you to use. And at any point, if you ever see a rate tariff utility not in our database that you need to, we have a full rates team ready to help you out. Just send us the electric bills. We'll go ahead and create that and add that in the database for you guys to use. And just to kind of show you, we're looking at rate tariff R, right? So it's a nice residential rate. And what I really wanted to show you here is something that Marissa earlier had touched upon is updating those rates. So you can see here, rate tariff R. Yeah, you can see we started updating this in 2014. And as I kind of scroll up the list, you can see that this rate is changed almost every single month. So our rate team does a phenomenal job of updating and keeping our rate database most current and accurate. So today we're going to reference the most recent rate tariff update here, April 2019. And a couple other things here I just want to show you. So we have our metering type. So when we're talking about CGS Plus and CSS, right, we need to make sure that we toggle the metering configuration to no net metering, fixed rate for all exported energy. And we're going to start off here using the export rate for Oahu at 10.08 cents per kWh exported to the grid. But we do fully accommodate other metering configurations as we do operate in all 50 states and internationally. And then moving on down, so just an overview of what we created today. We just did a residential profile, keeping it really simple. We just did 1,000 kWh usage, every month for a full year. Okay, just kept it really simple, 12,000 kWh consumption annually. And what we're going to do here is when you're inputting monthly electric bills, and this is a very important thing I want to showcase here about ETB, is that certain markets you're not able to get interval data, right? And Hawaii is kind of one of those markets. It's kind of hard to come by. So mostly we're working with electric bills. So we give you the ability to input your customer's historical consumption, okay? And this will vary the structure based on the rate tariff. At this time of use, we'll have that structure and charges already set up for you. And then we're going to ask you to reference a load profile type. And what this means is that we're giving you the ability to select what specific type of building your customer has. And every specific building has an entirely different energy profile curve. So for example, a residential structure, as we're going to reference from the Department of Energy and OpenEI, has a certain kind of pattern that is absolutely unique to a residential structure that's very much different than, say, a non-residential structure. In which case we have 16 different building types for you to select from to match up the energy consumption patterns of your customer and match that up into Energy Toolbase. So today, what we're going to be actually looking at here is reference. So we actually give you the ability to reference a custom interval data set. So for example, you can almost build your own data sets. We can help you do it to reference in order to create a unique energy profile. So today we're going to be referencing a residential energy profile where the homeowners are gone during the day. And just kind of showing you here what it would look like. We're going to open up our seasonal load profiles. And this is a fantastic just overview of what the customer's consumption pattern looks like per season. So here we're going to look at the winter, right? So here we can see that there's an influx in energy in the morning, and then naturally with people gone during the day, it drops during primetime solar production hours, and then it ramps back up when people get home later at night. Then over here we can see the weekends with an entirely different energy pattern as people being home throughout the weekends. This is an important thing to understand as we move forward, because what we're going to do is take this pattern in your total consumption and we're going to create interval data. Okay, so from your monthly bills, we're going to turn that right around, make interval data. So when you produce solar PV in our system, we're going to overlay that on top of interval data, which is one of the reasons why we are the most accurate software to calculate the savings in the industry. So if there's any questions about this, please type those in the comment box and we can get to those at the end of the webinar. So now moving forward, we're just going to dive right in. So here's a couple proposals that I went ahead and created. So the first one we're going to look at is CGS Plus. Okay, so let's open this right up. And Tracy, also just let me know if there's any screen lag here and I'll absolutely slow down. Okay, so looking at this, first of all, we're going to go right here to step 2. Okay, so in step 2, we give you the ability to model rate switch analysis and different scenarios that a customer may qualify for rate switches. What I really want to show here is that we're going to have the value of our exported energy at 10.08 cents. Okay, and this is what's going to be the export rate for Oahu. Now, the next thing I want to show you here is just what system that we designed. So I'm going to click right into step 4, and we're going to open up our PV design page through PV Watts, which is free when you sign up for our software. And what we went ahead and designed for you was a 6.5 kilowatt system. We priced it at $3 per watt. It's a very, very standard baseline price for most residential systems. And we just, did a 10-degree tilt, 180 azimuth. And we also give you the ability to do a detailed array where you can actually preload custom equipment that you may want to use in projects. But for today, we're going to keep it very simple, just do kind of a generic 6.5K system. So the next thing I want to show you is just some of the outputs and the results of what we're getting with the export rate for Oahu under a CGS Plus program. So as I stated, 6.5K system. Now this system is offsetting 84% of our customers' consumption. So very reasonably sized systems, nothing crazy, okay? And a couple things I really want to showcase here is what our blended PV savings are as compared to our utility cost, blended savings or blended cost, and also what we're exporting to the grid. And this export percentage is a very important thing to understand. Okay, so at 65%, what this means is that of all the generation that we're creating with our system, we're sending 65% of it back to the grid. Now under CGS Plus, that's fine. But with CSS, as you're going to see, this is going to pose some issues, and I'm going to show you the solutions of how we handle that in Energy Toolbase. So really quick, blended utility costs. So really easy thing to understand here. We're going to take the entire electric bill before solar, divide that number by our consumption. So we're going to see an average cost of 30.8 cents for customers using that electric. But our blended PV savings, okay, under this program with that export rate, we're going to take the total savings from this project and divide that number by the PV generation to get the value of what this system is producing per kWh generated. So here we're looking at 17 cents. And under this program, right, with modeling in Oahu with a very reasonable system size, our payback period is 7.3 years. That's not bad at all for a residential system at all. Now, really quick, I'm gonna hop up into ETB Analytics and we're gonna go to our demand visualization. This is a very, very powerful aspect of Energy Toolbase. It really showcases the power of our analytics, but also shows developers visually what they're actually building. So under a CGS Plus, okay, we have, just starting off, let's take away these values. So here's our customers' consumption, right? Almost exactly what we saw under that kind of generalized seasonal profile we looked at just a minute ago. So we can see here our usage is low during the day, ramps up in the evening. Now we're going to go ahead and overlay our solar PV generation. Okay, so as you can see, right, it's sunny in Hawaii all the time, and we're really cranking away with that solar generation. So when we're greatly exceeding our consumption, we have to export to the grid. Okay, with a PV-only system, that's where it's going. Now under CGS Plus, that's totally fine because we're capturing credits for those exports. So let me just go in here and I'm going to model really quickly. Let's say, for example, under the same CGS Plus, let's model as if we're doing a program in Lanai, for example, right, where they have an export rate at 20.8 cents per kWh. Now, previously, right, we have a 7.3 year payback for the export rate on Oahu. So let's go up here and save this, and let's take a look at how these are going to change. Okay, so look, so now our payback period drops to 5.3 years. We're getting more value for that exported energy with the exact same system. Okay, still exporting 65%. But take a look at our blended PV savings. Okay, our blended cost is the same, but our PV savings shot up to 24 cents because we're adding so much more value to the project by increasing the export value. So now what happens if, for example, we want to do standalone solar PV, but we want to use a CSS program, customer self-supply. So all I'm going to do here and how we handle customer self-supply is under the export rate, we're just going to put that to 0. We're going to hit save. Now, before I hit save, keep an eye on the payback periods and the blended PV savings, and you're going to see these change. Okay, so just by taking away the value for those exports, our payback period went up to 11.2 years. We're exporting 65% still, but our PV savings dropped all the way to 10.4 cents. And this is a really key indicator to let you know, hey, you know, by making that change, we took a lot of value away from that solar PV system. Okay, but another problem is occurring here, right? Under CSS, we cannot be doing this. We cannot be exporting energy to the grid. Okay, so that's a big no-no here. So what are the solutions? Well, there's two basic solutions here. So the first one is to reduce your solar PV size. Okay, so if you're doing standalone solar PV and you find that you're exporting to the grid, you need to reduce the size. But the problem with that is that under a CSS program with PV only, right, reducing it to the size to where solar only is going to be not really exporting, you're going to have to build, in this case, a 0.8 kilowatt system. And for most developers out there, it's just not worth it. Who's going to go sell a 0.8 kilowatt system? Like nobody, right? So this is an issue, okay? And this is really quick. This is our Etb Optimizer, which basically analyzes the customer's consumption, the rate tariffs, and the project to show you various system sizes and just what, you know, value opportunities are available as we scale up the size in kilowatts. Okay, so it's a great analytical tool. But heading on back to this, right? So in this case, scaling down solar PV is really not a viable solution here, right? So what's the opportunity? What's the answer? Well, the answer here is going to be pairing our solar PV with storage. So now I'm going to open up a project here that we made that holds our energy storage as well. Now, this is the exact same solar PV system, okay? It's a 6.5 kilowatt system, exact same energy profile, but I have a Tesla Powerwall modeled, okay? So all I did is I actually went ahead and paired that with our Powerwall. So all we have to do is you can preload our Tesla Powerwalls. You know, here I have a variety of other, you know, systems that, you know, you can program in and choose from or create your own custom energy storage. And I'm using one system, one Powerwall. I priced it very reasonably at $12,000. And right now we're looking at our Energy Toolbase portal and looking at the control settings you can define and how you want these to operate. So we're going to basically define this as, hey, we're going to charge from solar PV generation only, and we're going to run the algorithm of a self-consumption. So basically, we're going to charge from all those exports into the capacity of that battery and store that to discharge later to offset our imported energy. Okay, so just from adding one Powerwall with the exact same system, our exports dropped to 21%. Okay, we have a 9.3 year payback. So it's already looking a little bit better. So let's just take a look here visually and see exactly what's happening. So here under demand visualization, we're going to go ahead and open this up. So what I really want to show you here, right, is this red line is going to represent our battery state of charge. And see here, we're entering the day at a 5% state of charge. And now what normally we would have been exporting all of this solar PV generation, we're actually capturing those exports, charging our batteries with that, and we can see our state of charge increasing. But what's going to happen here in some cases, we're reaching our battery capacity limit. Once those batteries reach full capacity, we have no choice. We have to export to the grid, which is represented in the light blue right here. So now that our battery's at full capacity, we're going to store the energy and discharge that later on in the day to offset our imported energy right here. So after solar PV kind of winds down for the day, we have all that energy stored up. We're going to discharge that to offset imported energy. So we're going to discharge down to 5% and repeat the very next day under the exact same strategy. So this still poses kind of a problem here, right? We're still exporting 21%. We can't do that. So what's the solution? Okay, well, again, the solution is going to be at the discretion of the developer, right, and installer. Either decrease your solar PV size, which will decrease the generation and the exports, and then this battery should have enough capacity to store all the exports, right? But if you don't want to decrease the system size, another solution here is, hey, let's just stack 2 power walls right on top of each other. Okay, so in our power wall design, we're just going to model 2 of those. And now let's take a look at our exported energy, right? So not only did our payback period drop from 9.3 to 7.8 by stacking 2 of those power walls, but our exports dropped all the way down to 2%. And what I want to really showcase here is just showing you the change in that visualization. So before, right, we were charging from solar, we reached our capacity limit, we had to export to the grid with 1 power wall, but by stacking 2 of them, we have enough capacity to eat all of those exports just about. There's still a little bit here that kind of slipped through. And again, you can just downsize your PV just a little bit and get rid of those. But with the CSS program, pairing solar with storage is a very, very viable opportunity to really get the most out of this type of program.